Hello, students, and welcome to our lesson. Today we'll start talking about the properties of real numbers. It's February 3rd today. For our Do Now, we are going to respond to a special How Are You prompt. Today we will be learning about the properties of real numbers, and our essential questions are as follows. What are the commutative and associative properties? What are the identity and inverse properties? What is the property of zero and what is the distributive property? Remember, we're talking about real numbers. We talked about rational numbers, which include natural numbers, whole numbers, integers, and we talked about irrational numbers, which are numbers that do not terminate or do not have a repeating decimal. So all of the real numbers have the properties that we're going to be talking about today. So our assignment will be to answer the Do Now, which is in our Teams Q3 folder, our class notebook. Watch the video, complete the 2 pages that we have assigned today on real numbers, real properties of real numbers, and answer the exit ticket and class notebook, and please show me your completed work. So for our exit ticket, we will review the commutative, associative, identity property of addition, and the identity property of multiplication. Remember, show me your work at the end of the period, even if you're not finished. If you are not finished, you can just complete it for homework. Let's remember to have our camera on. Respond when your name is called at the beginning, middle, or end of the period. You have to stay through the whole period. Show your work on camera at the end of the period so I see what you've done. If you have questions, send me an email. Map testing begins tomorrow, February 4th, and goes through the 5th. We'll have 2 days at the end of next week as well. We will test for the first 2 hours, and then we will have 7 short periods for the remainder of the day. So here's our Do Now today. It's a little bit interesting. Basically, it says, how are you? This is all about you. How are you? Rate the following areas of your life. Add an arrow to show if it's getting better or worse. So 1 would be not so good and 5 would be great. How's your social life? Oh, me, not so great. But I hope as everybody gets the vaccine and we can not be so afraid of COVID-19, I'm hoping that it will go in the right direction. Am I having fun? Okay, I'm having some fun. I think maybe that is getting better as well. And schoolwork, you rate yourself and tell if you are getting better. It's the beginning of the 3rd marking period, so it's a good time to make changes if you need to make those changes. So rate yourself, check in with yourself, how you doing, and add an arrow to show if you're getting better or worse. So if you want to say anything else about that, you can do so here, but really this is all about filling out the chart. Here is our exit ticket on the properties of real numbers, and we'll get back to that. So for now, let's get started on our lesson. So properties of real numbers. In math, properties are statements that are true for any of the type of number, in this case, real numbers. These properties justify steps when simplifying expressions and solving equations. So let's talk first about the commutative property. To commute means to travel. And what does that have to do with it? Well, the commutative property tells us that order does not matter but there's a catch. It works for addition and multiplication only. So order does not matter. So what do we mean? Well, in case of, let's say if we use variables, we could say A plus b equals b plus a. If we were using numbers, we could say 7 plus 5 equals 5 plus 7. In either case, we're going to get 12. In expressions that are separated by addition and subtraction, we could say 3x plus 2 is the same as 2 plus 3x. Or we could say y plus 9x equals 9x plus y. So let's look at some multiplication examples. We could say that a times b equals b times a. We can say that ab times 7 equals 7 times ab. We can say that negative 6y plus 4 equals, or I should say times 4, that should be a multiplication example. Sorry, negative 6y times 4 equals 4 times negative 6y. And we can say the quantity of x plus y times 3 equals 3 times the quantity of x plus y. So that's the commutative property. To commute is to travel. To associate means to group with. Like your friends are your associates. So the main idea with the associative property is that grouping does not matter when it comes to addition and multiplication. So with addition and multiplication, grouping does not matter. Oh, some addition examples. We could have the quantity of 8 plus 9 and then added to 7, or we can ungroup the 8 plus 9. We can have 8 plus the quantity of 9 plus 7. So in terms of GEMS in the order of operations, 8 plus 9 is 17, plus 7 is 24. Or we could have here 9 plus 7 is 16, plus 8 is 24. Either way, they both equal 24. With variables, we can have x plus y as a quantity plus z, or we can group y and z, so we would have x plus the quantity of y plus z. Or even with a combination of numbers and variables, we could have, for example, 6a plus the quantity of 2 plus y, or we could have the quantity of 6a plus 2, and then that is added to y. And finally, we could have 6 plus the quantity of 3a plus 1, and that would equal the quantity of 6 plus 3a, to which 1 is added. In terms of multiplication, we can say a times the quantity of b times c equals the quantity of a times b times c. In terms of numbers, we can say 7 times the quantity of 2 times 1 equals the quantity of 7 times 2 multiplied by 1. So in the first case, on the left side, we would do 2 times 1 is 2, and 7 times 2 is 14. On the right side, we would start with the parentheses and say 7 times 2 is 14, and 14 times 1 is 14. So either way we do it, both sides equal 14. We could have 6x times the quantity of 2y times 3, or we can group 6x with 2y, so 6x times 2y, and then multiply that times 3. Either way doesn't matter because the associative property says that the grouping does not matter. So let's do one more example. 4a times 3b times 5c, or we can group 4a times 3b and multiply all of that times 5c. Now, moving on, we have the identity property. The identity property allows us to keep the value of the number. So we have an identity property for multiplication, and we have an identity property for addition. In terms of addition, we can add 0 to any number, and it will not change the number. We can add it to a variable. It will not change the variable. So here we can add 0. So, for example, 9 plus 0 is still 9. X plus 0 is still x. 4a plus 0 is still 4a. And negative 7g plus 0 is still negative 7g. Now, with multiplication examples, we can multiply by 1. So, for example, 7 times 1 equals 7, or 1/4, even with a fraction this works, times 1 equals 1/4. We can use an expression, 6x times 1 equals 6x, or negative 3b times 1 still equals negative 3b. And so that's the identity property. The identity property allows us to keep the value of the number. Now, the inverse property uses the opposite to eliminate or cancel out a value. So in addition, if we want to cancel examples in addition so that we have 0, and we are given 10, well, we can add to 10 negative 10, which will give us 0. Or we can have 1/2, and we can add negative 1/2, which will give us 0. Even with the integers, we can have negative 7, but we'll use the opposite. We'll add the opposite, which is positive 7, which add to 0. And even with a variable, we can have x and add to the x negative x, which will cancel those out and give us 0. Now with multiplication, we can multiply anything by its inverse in order to get 1. So multiply by an inverse to get 1. So for example, 10 can be thought of as 10 over 1, okay? So we're just going to call it 10. can't seem to get rid of that, but that's okay. The opposite or the inverse of 10 would be 1/10. So 10 multiplied by 1/10 equals 1. Negative 1/3 multiplied by by negative 3 would give us a positive 1. Negative times a negative is a positive. B multiplied by 1 over b would equal 1, because we would end up with b over b, which equals 1. Or in terms of rational numbers, fractions, 5/4 times 4/5 gives us 1. And now the property of 0, very briefly, tells us that anything multiplied by 0 equals 0. So we could say that 5x times 0 equals 0. We multiply anything by 0, there's nothing left. It even works with a quantity. If we have x plus, let's say 7y, and we multiply that by 0, we'll just get 0. And now the distributive property, which is one you'll also be using a lot, tells us that multiplying a value to an expression in parentheses is the way we distribute. So using the distributive property is multiplying a value through, I like to use the word through, every expression. Or term in parentheses. So let's say, for example, if we have 5 times the quantity of x minus 2, that would equal 5 times x is 5x, and 5 times negative 2 is negative 10. If we had 1/2 times the quantity of 20x minus 4, 1/2 times 20 is 10, so that would be 10x. 1/2 times negative 4 is negative 2. If we had a, now I have variable examples here, multiplied by the quantity of b plus c, well, a times b is ab, and a times c is ac. And if we have an integer outside of a quantity in parentheses, in this case x minus y, negative 7 times x is negative 7x, and then negative 7 times negative y is positive 7y. So we're going to look at these examples at the bottom of the page, name that property, and see which property we're looking at. So here we have 4 plus this grouped property of a plus b, and on the other side we have 4 plus a grouped together, and that is the associative property of addition. In the second example, we have 2 times the quantity of x plus 9 equals 2x plus 2 times 9, and that is a distributive property, and you should actually just write that 2x plus 18, so that's the distributive property. In the third example, we have 2x times 1 equals 2x, and that's the multiplicative identity property of multiplication. And in number 4, we have m plus n plus 3 equals n plus m plus 3. So first we have m plus n, then we have n plus m. And all we've done is we've had the m and the n just traveled. They just switched places, and that's the commutative property of addition. In number 5, we have 5 minus k as a quantity times 0 equals 0. Of course, that's the zero products property. In number 6, we have 7 times the quantity of w plus 3, and on the right side of the equation, we have w plus 3 as a quantity multiplied by 7, and that's the commutative property because the 7 traveled, the commutative property, but this time of multiplication. In number 7, it says, name the additive inverse of 16. That would be its opposite, and that would be negative 16. And number 8 asks us to name the multiplicative inverse of 3/7, and that would be 7 divided by 3. So that's your introduction to the real property, the real number properties. And let's review them. We can review at least some of them in our exit ticket. So, first of all, the commutative property, order does not matter. So a plus b equals b plus a. 2 plus 5 equals 5 plus 2. And the associative property, the grouping does not matter. So we can say a plus b plus c equals a plus the quantity of b plus c, or we can say 2 plus 1 plus 4 equals 2 plus the quantity of 1 plus 4. Either way, we're going to have 7. And remember, the commutative property works for addition and multiplication. There is no commutative property of division or subtraction, and the same with the associative property that works for addition and multiplication. Now, the identity property of addition means that we keep the same value of a number and we do that by adding 0. So 7 plus 0 still equals 7. And then the identity property of multiplication means we keep the same value of a number, but this time by multiplying by 1. And we can say 7 times 1 still equals 7. So I hope you're getting your work done during class or finishing it for homework. Practice, practice, practice is so great for math. And I know as you continue to practice, you'll be great.